And so good evening, and welcome to our first episode of the Sunday Night Astronomy Show. Welcome everybody. Let's hope that this is coming out nice and clear. We're going to be waiting. We've got about a 30-second delay or so here on YouTube. So we're watching the live stream on YouTube as well, and watching for your comments coming through. My name is Chris Kerwin. I run the page Astronomy by the Bay. I'm also on Facebook and Instagram and Twitter. And with me tonight I have Paul Owen. Paul is our resident astrophotographer and a member of the Royal Astronomical Society of Canada. He's also a member of the St. John Astronomy Club. And I also have Mike Powell on here with me. And Mike is our equipment manager. Anytime anything breaks or anybody's in trouble, Mike's there to bail you out. Mike is also a Royal Astronomical Society of Canada member. We're all from the chapter of the New Brunswick chapter, and we're all amateur astronomers. And all we're trying to do here is to be able to offer you some views of the night sky through the eyepieces of our telescopes. So what's going to happen tonight and how it's going to work is that Mike and Paul are both connected to their telescopes in their remote observatories. And we're going to offer you images of what we can see in the night sky. Tonight we'll be offering possibly 4 targets as total. Just checking comments here, making sure everything's up and fine. Yeah, I guess volume must be good apparently.
Yes.
Yeah, okay, so we're going to be offering you a few targets through the night sky, 3 to 4 targets tonight at maximum. One of them is almost set, so Mike's going to be our first guest on here. And when we switch over to Mike, Mike will offer you a view of what's called the Ring Nebula. That's going to be our first target. And I'll be talking a little bit more about the Ring Nebula and what we expect to see. So what's going to happen is that Mike is capturing a view of the Ring Nebula, and he is what we call live stacking. So he'll take the image, and the camera itself through the software will take a second image about every 5 seconds or so. And then that image will be put on top of the last image. So the image should start to get brighter and brighter. Now these objects that we're offering you are all available through the eyepiece of the telescope. If you come out to the telescope and take a look through the telescope with us, you'll be able to see these targets. This is me up in the top right hand corner. We've got Paul and Mike here on the screen. So let's first of all switch over to Mike so we can get Mike's target before it sets on us. So we're on Skype right now, and Mike's going to start sharing his screen. So just bear with us for a moment.
I just wanted to bring up this wide field view of the night sky, and you can see how close Lyra is getting to the top of the tree. So if my image starts to fade out a little bit, I'm moving into the twigs. We should be fine for a little bit. If you look and watch the arrow on the screen, you can see that's Vega there, and this makes the square.
The image starts to fade out.
Lyra.
The twig. You should be fine for a little bit.
All right, let's go to.
Okay, so this is the view out through Mike's observatory, and what he has right there now is the summer triangle. So the 3 stars that we, 3 bright stars we saw there, were part of the summer triangle. And now we're looking at the object that we had suggested that we brought up for a target tonight.
Oh, there's the Ring Nebula. It's a little bloated, but you can make out the colors. You can look closely and see the central star. It's stacked now with 41 images.
So Mike has stacked 41 images. At how far apart are they, Mike?
I'm running 11.6 seconds apart.
Okay, so every 11.6 seconds, Mike's capturing an image there, and he's stacking it on top of the image just before it. So what we're seeing is what we call a nebula. And when you think of the stars in the night sky, they might seem like they're eternal, but we know better. In fact, the vast majority of the brightest stars that we see are either very bright, young blue giant stars that are destined to be short-lived, or old red giant stars that have burned through their majority of their fuel. And in both cases, these stars are nearing the end of their lives. But did you know that just beyond the reach of your naked eye's capabilities lie a number of these recently deceased red giant stars that were bright, shining stars just a few 100,000 years ago? So these are the ones what we're looking at tonight. And we call these nebula, planetary nebula. Now they have nothing to do with a planet. at all. But back during the 18th century, there's a famed French astronomer. His name was Charles Messier. And he noted the presence of several nebulous objects in the night sky. So he was a comet hunter. He was looking for comets, basically. So after having originally mistaken some of these targets for comets, he started compiling a list together so that others would not make the same mistake that he did. And then eventually, in time, his list became known as the Messier catalog. And it would come to include over 100 of the most fabulous objects in the night sky. So this is one of the targets we've got right now. This one's called Messier 57. And it's called the Ring Nebula. So we're going to let this stack for a little bit and just talk a little bit about it. So high up in the summer skies, immediately after sunset and through most of the night, is the summer triangle, which is the asterism that we looked at earlier. It consists of 3 stars. There's Deneb, Vega, and Altair. And those are part of 3 different constellations. And that dominates a huge portion of the sky. So if you went out tonight and took a look off to your western sky right now, just about to set, are 3 really bright stars, and they form this summer triangle.
You want me to bring that up for a second?
Yeah, if you could, Mike, that'd be great.
So there it is there. There's Vega.
Just a second, I'll get it back up on the screen.
Altair.
There we go. So yeah, Vega, Deneb, and Altair, those 3 stars that Mike's pointing to there now are the summer triangle. And where we're looking is beside Vega. And just beneath Vega, towards Altair, there's a parallelogram there made of 4 prominent stars. And along with Vega, they make up that constellation of Lyra. So can you point out Lyra there for us, Mike?
There's Vega. There's
The 4 stars that make up the parallelogram.
And
So
then
we're looking right in between those 2
Yep,
stars
right in
right
here.
there. That's where we're seeing.
where the arrow is.
So the Ring Nebula, or Messier 57, is practically right in the middle of those 2 stars. And it's really not visible in binoculars, just barely visible if you know exactly what you're looking at, or a small telescope. It looks much, much better in a larger telescope, of course. And it resides about 2,283 light years away from Earth. And so 1 light year is 10 trillion kilometers. So we're seeing, the other thing about this right now is the images that we're seeing right now tonight, these are live stacked images. But the photons of light left the Ring Nebula 2,283 years ago, traveled through space, and are landing on the chip of Mike's camera there tonight. So we're seeing the Ring Nebula as it was over 2,000 years ago. And the Ring Nebula is actually about 1.8 light years across, so it's very big. With your naked eye through a large telescope, you might indeed be able to see that it's more than just a faint fuzzy object. You might be able to see more like a donut shape. That's what we see, but we don't see color with our eyeballs either at night. So, but you can certainly make out the distinctive ring-like shape there. And it has a dark interior, and probably even a central point at the middle of it all. So really what we're looking at is the death of a star, similar to our sun. So if somewhere out there, someone was looking back at us in 4.5 billion years, this is what we would look like. Once our star finishes its consumption of hydrogen and starts to consume helium, then it starts to swell, and it'll become a red giant. And once the star gets so large that it can't hold on to the outer layers anymore, they escape off into space. And then all we have left is something called a white dwarf. So our sun right now would hold about 1.3 million Earths. And all that will be left behind is something about the size of our Earth. So it'll certainly contract quite a bit in size. And then you're left with this large gas cloud that's left behind. And this gas cloud is what is used to produce new stars and new planets eventually. So all the material that we see in the night sky is recycled. It's all recycled stardust. I'm going to flip back to comments here occasionally, so that I can keep an eye on what's happening and see if there's anything, any comments that are coming up. Remember, this is a live stream, so I am watching comments as they come by. So if you have questions along the way, please feel free to shout them out. As the guys are stacking their images there and keeping control of their telescopes and their images in the view, I'll be offering some comments, and Paul's going to join in here too with some pretty cool comments on some of the objects that we're looking at. So if you see anything along here that you'd like to ask us about, please just go ahead and shout them out. The Eye of Sauron, Dave says. Cool. Okay, so let's talk a little bit more about the ring here before it sets. Well, actually, what we're looking at, every star below about 8 to 10 solar masses, so about 8 to 10 times the size of our sun, will someday run out of material that it can fuse in its core. And when these stars, including our sun, are done fusing hydrogen into helium, they become giant stars, where they'll fuse helium into carbon, and then whatever they can manage up to a limit of iron or nickel or cobalt, and then that's it for nuclear reactions. It can't perform nuclear reactions anymore. So for all that's left after that is for gravity and electromagnetism and the matter to do what they do. This means that the core of the star, containing most of the heavy elements, will contract down to a state of matter known as a white dwarf, and the outer layers will be gently blown off to eventually form a planetary nebula. This is what we're looking at. These are very rare. We have only a few thousand of these out of hundreds of billions of stars that are in our Milky Way. And only about 80% of them actually have an asymmetric shape. So about 80% of them are shaped more like an apple core than they are shaped like a donut like this. But the ring nebula is pretty special because it's very spherical. You can see. Most stars have either a binary companion, so they orbit around a central mass. So there's two stars together in most cases. Our star is kind of unique in that we don't have a binary companion. Or they have some other defining feature that makes them strongly different from just a single, roughly stationary mass at the center. But a substantial minority of stars, including our sun, have a single, slowly rotating mass dominating well over 99% of the mass of their local neighborhood. So our sun rotates at many different speeds. That'll be for a later show when we start talking about sunspots and offerings that we might be able to make through the daytime. But the bottom line is that our sun rotates at about 25 days around the equator, and then about 27 days, about half the way up between the equator and the poles, and then about 30 days at the top. So it does rotate pretty quickly. And that means that when it comes for time for our sun to run out of fuel and end its life, these stars will blow off their outer layers in an almost perfect sphere that we see here. This ring shape has different colors and brightnesses at different distances. So we can see that there's lots of different colors in the exposure there. There's greens, there's reds, there's yellows, and that all corresponds to the layers of the star that's undergoing its death. So we're really watching the death of a star here. And again, the image that we're looking at is over 2,000 years old because photons of light left that star or that nebula 2,283 years ago, traveled through space at the speed of light, and then ended up on the capture point of Mike's camera tonight. So not only is the outermost layer of this planetary nebula made of hydrogen gas, but it also extends far beyond the clear visible part of the nebula that we can see here. And it makes up an unbelievable 97% of the whole planetary nebula. And this is truly remarkable because only about 92% of the universe was made up of hydrogen before it had any stars, which means that the stars actually do a better job of separating hydrogen out from the heavier elements and returning them back into space than the universe did during the Big Bang itself. So they're very efficient at returning their material back into space. And again, that material gets collected out in space and it'll form new planets, new stars. So it's just all recycled stardust. What we'll get into too in future shows is, so we're looking at the death of a star here, a star in its dying days. And in other times, when we look at things like the Orion Nebula and the Pleiades star cluster, which we'll offer in future weeks, we'll be looking at stellar nurseries, areas where stars are actually being formed from the leftover dust from other exploded stars. all stars don't just go supernova. They have to be much bigger than our sun to actually be able to go supernova. So again, with our sun, it'll just get larger as a red giant, and it won't be able to hold on to its outer layers anymore, and it'll basically escape off into space. So the remaining colors here are dominated by the heavier elements, with emission lines in the visible part of the spectrum, including doubly ionized oxygen, molecular nitrogen, molecular sulfur, and helium. So that's what's causing all the different colors. About 2% of the whole planetary nebula is actually helium, and about 1% is the heavier elements combined. That's where we get all the heavier elements that our planet is made of. The vast majority of the heavier elements, which allowed the star to shine throughout its life, are actually locked up inside the white dwarf that's contracting and cooling at the center. So if we could get a much bigger view here, you can almost see that there is a central star in the very center of that. Again, we're looking 2,000 light years away, so the limits of the camera, everything that we offer you on these live feeds are going to be things that you can actually come to the telescope and see through the eyepiece. You may not see it directly like this, you won't see it with color, but we use what we call the receptors on the side of our eye, and we can look at objects with our side of our eye, which is much more sensitive to light, so we can actually pick up this donut shape pretty easily through the telescope. The inner regions are much hotter, which explains why they're far brighter, as the electrons falling down their orbitals that cause the emission of the light that we can see. So that's a lot about the Ring Nebula. I'm going to flip back to the comments here.
What we're going to be doing as well, too, Russ, if you don't mind, is at the end of each segment that we talk about the target, I'm going to give a little bit of a tidbit of information. Sometimes it might be oddities, sometimes it might be just little stories around the object that we look at, because we see things based on, in the astronomical world, scientifically, but there's a lot of fun topics and objects, or a lot of fun things that are written about these objects at the same time. So at the end of each one, I'm going to just kind of read one out, and I want to give a shout out to our fellow astronomy member Roseanne Armstrong, who's writing a lot and getting a lot of this information for us too. So it'll just kind of keep it fun and just little bits of information that we would otherwise probably not know about. So.
Sounds great. Thanks, and thank you, Rosanna, for your information. Really appreciate that. So any other questions? I'm just watching along here. Hi from Darlings Island. Hi from North Carolina. Carolina Sky Astronomy is on with us tonight. I see PFO Observatory on here.
I'm just making comments about
That's perfect. We're not going to keep this too serious, folks. We do enjoy having a laugh together while we're doing this kind of stuff. So we're trying to keep it fun. So may hear a little laughter here in the background. How big would the ring be? The ring is actually, it's about 1.8 light years across, so about 2 light years. And I believe our whole solar system is, if you want to go all the way out to the Oort cloud, there's been a lot of definitions about how big the solar system really is. And the thing is, how do you define the solar system? Is the solar system the sun and the 8 planets, or to Pluto, or does it go out past Pluto to the Oort cloud? And does it even go out past that? So what's happened is recently we sent a couple of spacecraft out there called Voyager 1 and 2. And they've been traveling for 42 years, I guess now. They were launched in 1977, traveling at about 17 kilometers per second. And they are now in the space between the stars. So they've measured the sun's influence out as far as they could. In other words, the sun emits solar wind pushing out against the galaxy. And the galaxy, of course, from exploded supernova and things like that are pushing back in. So there's a balance point there between where they both meet. Now, when the solar wind is pushing out, we had instruments on the 2 Voyager spacecraft that were able to measure that solar wind and measure the plasma stream. And it got to a point where the level, of course, on the way out was much stronger than it was from pushing back in from the universe. And then it got to a point where it took a number of years to pass through a spot where they were both basically equal. And when they were equal, then both streams were met together and they canceled each other out. Well, now we're now actually measuring the stream coming from the universe back in at us. So both Voyager spacecraft have left the bubble, the heliosphere they call it, that surrounds the sun. So they are both in interstellar space. So we could say that they're going to be another light year at least before they reach the Oort cloud. So do we say the solar system is 2 light years wide? But anyway, the whole thing here, I guess Carolina Sky Astronomy commented back saying that it's 1.3 light years. And I'm not sure if that's radius or if that's the actual this, but I guess I'd have to assume that that's the actual width of it. So 1.3 light years, very huge. And on a future episode, and actually back on my Facebook page, but I'll try to put it up here on YouTube too, the size of nebula compared to our solar system. And they're just massive. They're huge. Thanks for that comment there, Carolina Sky. Appreciate that. I guess it's Jim, I guess is the name. Yeah, that's great. Yeah, also, and Carolina Sky makes a good point. If you're enjoying the live streams that we bring you through this method, please consider just hitting the like button and being sure that you subscribe to the page, because the more you do, the more we'll be able to share this. So. Okay, so we've got I guess we're done with the ring now, Paul, or Mike. I'm sorry.
Well, just before we run away,
Okay.
any of you technical geeks out there are wondering what we're using for equipment at my end.
Yes, please. Yes.
This is a 66 millimeter William optic APO. I'm using an Altair 224 camera, I believe it is, Chris. It's Chris's camera.
Yeah.
And then that's mounted on top of my C8, which is on the Skywatcher EQ5 mount. And then we're using SharpCap 3 Pro as the software to do the capture. And that's what I've got running on my observatory. So,
Richard Hashi asked, "Are we?" He may have missed the beginning. Are we stacking at the same time? Yes, we are stacking, Richard, every 11 seconds or so. So
yeah, I'm up to 130 frames there now.
there's 130 frames at 11 seconds. So 66 William Optics with the camera mounted in it, and it's mounted to the C8 or 8-inch Smith Cassegrain telescope on an EQ6 mount.
Yep.
Yeah. And it's remote controlled, so this is how we're offering this live stack. It's tracking, of course. So.
Yeah, I'm on a remote desktop, so I can sit up here in the garage where it's nice and warm. I don't have to sit out in the observatory where it's cold.
And that's the whole idea of doing these live feeds for all of us throughout the winter here. It's going to be a once a week. We're hoping to keep it as once a week Sunday night show here. So, and the idea is to get us out of the cold a bit too. So we'll have we don't get a whole lot of visitors at the eyepiece during this time of year. That's typical.
All right.
Okay, thank you, Mike.
Give up the screen there and pass it on to Paul.
Okay, that'd be great. Thank you, Mike. And Paul, I guess we're back to you now.
Okay, let's see if I can bring up my screen. Tell me if you see it.
Okay, nothing yet. Here we go.
Okay.
And that's a picture of two of us. So there we go.
There.
Okay, can you see that now?
We do, yeah.
Yep, all right. Just give it a moment there and we'll get that nebula up for you. There we go.
Perfect.
Okay, so what I'm showing here, and I'm going to give it over to Chris, he's got all the information on it, but I'll give you the techie stuff first. So this is the Dumbbell Nebula, and M27 is the catalog name for it. And again, I'll let Chris describe what it is. What we're looking through here in my backyard observatory is a stellar view 105 millimeter refractor. It's a triplet, so there's 3 pieces of glass in there to kind of keep the colors all nice and clean. And I'm using a ZWO MC 294 MC Pro, which is a CMOS camera, and it's a 4/3 sensor, so it's a good size sensor, so it can pick up a lot of different size targets with it. And again, I'm running the same as Mike, an EQ6 Skywatcher equatorial mount, and that's what I'm providing this view with tonight. And I want to say a hi out to Zaman. Hi, Zaman.
Excellent. Thanks, Paul. Beautiful view there. So Paul's using a bit of a different camera, and Paul's located in New Brunswick as well. And this is kind of a neat thing for us because we've wanted to do this for a little while now, but we haven't been able to pull it all together. But really happy that we're able to offer this out to everybody out in YouTube land, I guess. And this is a live stacked image. Paul, how many images would you have stacked there now?
Right now I'm at 334 15-second frames.
Okay, so every 15 seconds it's taking a picture of the sky, and it's stacking it on top of the last picture. So this is what it's allowing us to bring the image brighter and brighter on the screen. So over time here, we've got a whole lot more detail than, of course, he would have had in the very beginning. So we're looking at what's called Messier 27, or the Dumbbell Nebula, or it's also called the Apple Core Nebula. That's another name for it. And it's actually a very bright planetary nebula. It's the same idea as what we saw before. It's basically the remnants of a dead or a dying star. And not all nebula are the remnants of dead or dying stars. Others are the birthplace of new stars. So they can be the death of stars or the birth of stars. But again, it's all recycled stardust. So we're seeing stars in different stages of their life, basically. So in this case, the bright planetary nebula we're looking at here is the second brightest in the whole night sky. And actually the Helix Nebula is the brightest. But it's located in the direction of the Vulpecula constellation. I don't know if we can get that up or not. Oh. Vulpecula, we might be able to show that, Paul. Do you have Stellarium open or no?
No, I don't.
Okay. So I could offer a view from my laptop. If you wanted to unshare just for a moment, and I'll bring up where we're looking. Okay. So I'll see if I can get us to share. And start sharing. Just want to check my live feed to see what's going on here. Okay, so I'm going to try to go to this in Stellarium. Okay, so we'll see if that's coming up on YouTube. I'm watching two different screens here at the same time, so just bear with me. And there we go. Okay, so here's our night sky from St. John, New Brunswick, and what I've got up here right now. Can you see that, Paul, easily?
Yes.
Okay, so we got the summer triangle here, what Mike brought up earlier, and there was Vega, the bright star Vega, and we were looking at the Ring Nebula, which was right in between these two stars right here. So we're looking in the western sky, of course, right now. That's the summer triangle is called the summer triangle for a reason. At this time of year, it sets a lot earlier as we're getting into close to December. But we're going to go over to Vulpecula. I'll show you. I'm using a program called Stellarium, Stellarium, and it's an excellent free program that you can download. And once you download it, it will show you the sky like this. You can turn on and off lots of different menus down here in the bottom. And right now we're just going to do a search for it. Actually, if I just type M27 for Messier 27, you'll see it'll spin around to Vulpecula. That's the Fox right here, and it centers the object right there in the center of the field of view. So if I zoom in here some, we can see that there's the dumbbell that Paul has now got as a live capture. Now, this is the photo that's stuck into the program, of course. If I zoom back out, you can see that where we're looking is right within that summer triangle that's overhead. So here's the big constellation of Cygnus, the swan. There's the head of the swan. There's his body. There's his wings and his tail. This one right here is a nice little target too, Paul. That's another one we could offer sometime in Alberio. But anyway, we're looking at Vulpecula, the Fox, and we're looking within Vulpecula to find the Dumbbell Nebula. So to find that in the sky, if I took off that summer triangle asterism, I think I could do that right here. And we can see that here's Cygnus, So we look up and we see this large shape called the Northern Cross. I'll take off the artwork even right now, and then we're right back to just Cygnus, the constellation. And we're just a short distance across parallel. If we go across from Vega, straight over from Albireo, and we'll find Vulpecula and the Dumbbell Nebula right there on the left. Okay, I'll go back to you sharing your screen, Paul. Let me go just 1 second before you do. I'll get back on OBS and get us back to Skype. And back to the window. So I'll unshare, I guess. Stop sharing. And do you want to bring yours back up?
Okay.
And I'm just checking comments here. Thank you, Richard. Appreciate that. Nice show, he says. Dave McCashin. Good evening, sir. Thank you, Stephen. Appreciate that. My last video was a Ring Nebula, Carolina Sky. I subscribed to your page today, and I was actually looking at your videos, so they're quite interesting. Thanks for sharing those. I hope to get back and see the rest of them there very soon. Hi from Darlings, Ireland, from Smitterman. And good evening, Eric. Just going through some of the comments. Hey, Karim. And thank you for joining on. Lots of comments here and lots of folks on here enjoying the feed. That's great. So I've got 2 laptops set up here. I've got one that I'm watching the live stream as we're offering it, and the second one I'm watching the YouTube channel, which is a little bit of a delay, but trying to catch the comments as they come in through that as well. Yeah, sure. Be sure, folks, to go out and check out Carolina Sky Astronomy. He's got some great videos there. Really excellent from his little Mac scope there. He's doing an excellent job. Okay, I'm going to have to turn my comments down here. Okay, so we're still stacking.
Yeah, we're still stacking there, and the nice thing, I'll mention, is you were mentioning earlier about the color and how we couldn't really see it with our eye. And the nice thing about the stacking is, of course, is it allows you to see the color of the object, but also you can start to see all the different star colors as well, because various stars have various colors. For basically some are older, some are younger, some are hotter, some are cooler, and there are certain sizes. And just studying stars all on their own sometimes can be a whole lot of fun. So when you see a target that's got what they call a rich star field, which means there's a lot of stars in and around that object, especially when you get into the Milky Way. Yeah, when you're looking at targets like that, they're just surrounded by stars. If you want to just take and go star trekking sometime, no pun intended for the show, but there's so much to look at, and you can find some fascinating double stars and clusters, or just even stars that are, you can start pretending that, oh, what's that shape look like, and make up your own asterism. So it can be a lot of fun doing that too.
It's true. Yeah, learning your way around the night sky is the big trick, and we're all still learning for sure. So the dumbbell that we're looking at here is in the Vulpecula constellation, is a distance of about 1,360 light years from Earth. So again, we're looking at photons of light that left there 1,360 years ago, traveled through space, and ended up on Paul's camera tonight. So every time that you look up in space, we're really looking back in time. We're seeing objects as they were, not as they are at the moment. So, for instance, if you were on the moon and you had a really bright flashlight and you were shining it back at Earth, that'd be pretty powerful, I guess. But it would take about 1.5 seconds before you get the chance to see it, because it would take light that long at 300,000 kilometers per second to reach Earth. From the sun, it's about 8.5 minutes. So if something magically happened to the sun, we wouldn't know about it for 8.5 minutes, because it would take that long for the light to travel from the sun to our eyeball, 160 million kilometers away. Again, when we're looking at the next closest star, it's 4.3 light years away. So the light that we see from Alpha Centauri, or Proxima Centauri, I guess, which is the closest one, is actually 4 years old. So every time you look up in the sky, you're looking back in time. You're seeing objects as they were, not as they are in the present time, because it took light a long time to reach your eyeball from that spot. So in this case, we're looking at the Dumbbell Nebula as it was 1,360 years ago, and it's almost 3 light years across. So it's very big. It's located within the equatorial plane of the galaxy. And this nebula is essentially, it's really just a dying star that has been ejecting a shell of hot gas out into space for roughly 48,000 years. The star responsible is an extremely hot bluish subdwarf star that sits in the center there. Pardon me. And it emits primarily a highly energetic radiation in the non-visible part of the electromagnetic spectrum. So its energy is absorbed by exciting the nebula's gas, and then it re-emits it out by the nebula. Messier 27 has a particular green glow to it, hence the name Apple Core Nebula. And it's due to the presence of what's called doubly ionized oxygen in its center, which emits the green color. And even through a good-sized telescope, the human eye will only perceive this as a white object. Although the two lobed structures would be clear, you can certainly pick out the shape of a dumbbell with your eyeball. And it's a very clear. You don't have to actually use what we call averted vision. So that's when you turn your eyeball to the side, or you're using the side of your eye to look at the object. And you don't really require averted vision to look at this one, where you might with the ring occasionally. More common on, say, what's another one, Paul, that you might need averted vision for? The capture that you did there just recently.
Well, the snowball for sure.
Yeah, the snowball. Yeah.
Yeah.
There's one called the blinking planetary, which really does teach you about averted vision. So that's a really cool one. You notice that there appears to be a star at the center, and it's no mere coincidence. This once giant star has collapsed down to a dwarf size. So we talked about our sun being 1.3 million times the size of the Earth, and when it's completed its life cycle, it will only be the size of our Earth. But in this case, the dwarf is actually a tremendously hot one at about 85,000 K, so it's about 14 times as hot as the surface of our sun. The different colors are indicative of the different elements in different ionization states, with red being a telltale sign of ionized hydrogen. But if you focus in on the narrow band colors that other elements make, you'll find that something more than just simple hydrogen. The bright green glow that you see is highlighting oxygen atoms in their rare double ionized state, where it's missing 2 electrons. And how do we arrive at this configuration? With 2 lobes of hydrogen gas on the outskirts, which is really opposite the way that we saw the ring. When we saw the ring, it was really a spherical ball. And we have an ultra-hot dwarf star at the center. Well, the nebula is almost 48,000 years old, with many estimates placing it closer to 10,000 year range. But prior to that, it was a giant star burning through helium fuel in its core and hydrogen in its outer layers. And when the core ran out of helium fuel, it contracted and then heated up. And then the elevation and the radiation pressure first blew off the star's outer hydrogen-rich layers. But it didn't simply blow them off spherically, as our sun probably will, because Messier 27 is actually part of a binary system. So the second star, the one that's still burning through its fuel, helps eject that blown-off mass in the dual-lobed kind of shape that we're seeing there now. In fact, some of the mass of the original star is flung even farther than typical images of this nebula show. In addition to the hydrogen, the relative rapid contraction of the star causes it to heat up, and then these increased temperatures trigger bursts of nuclear fusion that can expel portions of the inner layer of the star as well. Among other elements like sulfur and nitrogen, that's where oxygen actually comes from. So the inner core of the star, it will eventually contract down to a white dwarf. a very hot star that shines because of the energy of its gravitational contraction. This core is about the mass of the Sun, but it's contracted down to only about the physical size of the Earth. So it stores a tremendous amount of heat and energy in the dwarf star. But because it's so small, it can only radiate this energy away very slowly. In fact, it will take about 10,000 times the age of the present universe for this object to cool enough to stop emitting visible light. In the meantime, the nebula is expanding as the gas that's gently blown off from this until recently just a normal star returns back into the interstellar medium, or the space all around it, where it will help form future generations of stars, planets, complex chemicals, and possibly life. When we're looking at a planetary nebula, we're really watching the part of the cosmic life cycle of death and rebirth over again. So it's a continuous cycle of birth, death, and rebirth that makes these nebulosities, these huge clouds, and what continues to regenerate new stars. Complete recycle of material. If you took a closer look at this with, say, the Hubble Space Telescope, you'd find that there are many knots of gas that are really rich in heavy elements that form inside this, and usually inside of all the planetary nebula. So enjoy this one in the night sky, the brightest planetary nebula, and think of all the hundreds of billions, if not trillions, of stars that already went through this process in our galaxy alone, just to help create the solar systems and planets and stuff that we have now.
So for those who are chiming in or online with us and are wondering why it's called the Apple Core Nebula, if you look at that red section of the gas, that's the hydrogen alpha portion of the gas. And of course, the bluer section in the center, right in about here, is more of the oxygen. And so when you look at the top portion of this and the bottom portion, just like one of those nice red apples you take a bite of. And so here's the apple core right there. Just in case for those people who weren't sure why it might be called the apple core. Some people call it the dumbbell. To me, it looks more like an apple core. And but anyway, that's just exactly what it looks like before you toss it in the can. Eh?
Great shot, Paul. Nice capture.
Yeah, it's looking really good. It's a really nice target to look at.
And we weren't
and when you're looking at this too with telescope, lots of times Mike and I'll take out our bino viewers and look at this particular target.
Right.
And it's a bright target, so it's one of these ones you can see quite well. But visually, in a dark sky with a relatively powerful telescope, this is really, you can almost see this whole thing minus the color. So it's really that bright. So.
Yeah, it doesn't have that quite distinct shape, I know, through the telescope. When you're looking at it through the telescope, you can see the lobes, of course, but you can see a lot of the nebulosity off of either side of it too when you're looking at it through the telescope. But it's really not a very sharp image.
No, but if you know when you start looking through telescopes, of course, and start getting a little experience with the eye, you can pick out the shapes. You can almost, with your mind, fill in the rest of it. So
right.
Yeah.
So nice capture.
Thanks.
How are you making out there, Mike?
I'm on a nice cluster.
Okay.
Yes,
I guess so. I guess we're running about 20 to 9 right now. So we're probably will the cycle ever stop? And McAllister asks, will the birth, death, rebirth star cycle ever stop? And so, under what conditions? That's a great question, and it's not known, I guess, whether it will ever stop, but it certainly will continue for billions of years at the moment. There's no reason for it to discontinue. All the stars that we see will eventually recycle their material back into space and eventually form new stars. There's still many areas, even in our own galaxy, and as we get into Andromeda and start offering Andromeda bigger captures from the Hubble Space Telescope especially, there are huge areas of starbirth that are happening in Andromeda. Also, even within our Milky Way arms themselves, as we spin, it takes us 250 million years to orbit once around our own galaxy. But as we do that, our star and our sun has actually changed positions many times as we rotate it, because the center of our galaxy would rotate basically at a different speed than it would out on the spiral arms. So material tends to collect or back up behind itself in the arms especially. So it forces stars closer together and forces material closer together, which causes more and more star birth. So at the present time, we're in a period of continuous cycle of birth and rebirth. I guess the final question there, under what conditions would it ever stop? I have to clarify here for everybody that might ask a question that I might not be able to answer. None of us are astrophysicists. All of us are amateur astronomers, and we are looking at maybe joining on the show at a later date when we'll be offering more panels, more of a committee that would have experts on there that could answer that question probably for you. We are amateurs at the eyepiece of the telescopes, and we know that's what we are, and we're quite happy to be where we are and to be able to offer what we can. But there's no doubt that we'll receive some questions that we just can't answer. But I will take a comment away, and I do know of a couple of people that might be able to answer that comment for you. Carolina Sky says, I hope we get to see Betelgeuse go supernova. Wouldn't that be fantastic?
Don't we all?
That would be the event of the century for sure, the event of our lifetime. I'm just looking forward to a nice total solar eclipse coming up on April the 8th of 2024. I was looking forward to the Mercury Transit. Yeah, with no cloud. Of course, it's the celestial event, so we'll be clouded out in St. John automatically. We usually are. We got, what did you get, Paul? Maybe 20 seconds or so of the Mercury Transit?
Yeah. It was about that, but I got it good. So it came good. It was the clouds actually helped a little bit to define the sun and Mercury. So I didn't have to do a whole lot of adjusting on the camera. So yeah, it came out pretty good.
Nice.
Yeah, I was just going to ask that actually. I was going to ask if Carolina Sky and the people from other regions if they did see the Mercury Transit.
Yeah, because it was such a. I mean, once we won't see another one here in St. John till I know the comments are 2032, but it's actually 2049 because we'll actually eclipse the sun in 2032, but it won't be above the horizon when it does it, so we won't get a chance to see it in 2049. Yeah, so we'll just hope for the 2024 event. Actually, on June the 10th of 2021, there's a partial solar eclipse that's going to pass in St. John, and it is about 82 or so %, which is fairly high. So we'll have a nice one like we had back in 2017 there. And actually, I think it's even larger than that. And that'll lead up to about between 4 and 6 total lunar eclipses that are going to lead ahead to our total solar eclipse of 2024. Now, it won't be total 100% St. John. It'll be about 98%, 98.5%. But you just have to go as far as Fredericton where you'll catch the totality. And actually, in March the 10th, I think it is, of 2025, we get another one right after it. So it'll be about 89 or 90%. So we've got a number of nice celestial events coming up in the future. Anyway, let's go over to Mike now, and Mike is going to be offering another image. So we're getting away from Planetary Nebula now, and while Paul brings himself to his fourth target or his second target, we're going to take a look at Mike's second target. Okay. And Mike is going to dial into an area what's called it's a W shape that's called Cassiopeia.
If you're seeing it now, I'm just waiting for it to refresh here, but this is almost looking straight up from my observatory floor, and there's Cassiopeia, the W right here if you follow the arrow. And the object that I am on, if you come up, oh, where'd we go? It kind of flashed on me. If you come up off the bottom of the W, right in here, It looks like a little dot. That is, I'll look to show you. All right, here is ET,
There we go.
NGC 457, the Owl Cluster or the ET Cluster.
The ET
Call it
clusters.
what you will.
So why don't you try to point out the shape of ET there, Mike, for us, so people can kind of make them out. So
For sure.
Yeah, I mean ET is only really since the movie ET, I guess, but it was called the Owl Cluster before that. I guess it's still called that, but.
So the two brightest stars are Phi 1 and Phi 2 Cassiopeia, which make up his eyes, these two stars here. Then you come down through his neck with his arms stretched out one way and his arms stretched out the other way. And then you work your way down the body, and there's his two little feeties down here at the bottom.
Nice.
For those who aren't as old as the rest of us, some people see it as Wall-E. As long as you figure or picture a person or some kind of a body in there, then you found the cluster. It's about 21 million years old, they figure. Made up in a full cluster is about 150 stars down to a 12 magnitude. And it's supposedly a naked eye image, but I can't say as I've seen it naked eye.
Thanks, Mike. I'm just reading comments here again. Jay Suleiman is asking, and speaking of white dwarfs, where is the nearest white dwarf? He was asking, his son was asking the question. And Carolina Sky, thank you for answering the questions here as we go along. I appreciate that because it's difficult to watch the images and the two screens at once, and you're catching up the comments. So he says the next nearest white dwarf star to the Earth is Sirius B. Thanks so much for your support there. Appreciate that. That is a nice cluster. Yes, it is. It's a nice open star cluster. So we have clusters of stars. So everything is gravitationally bound, of course. We've got our sun and our planets, and then our solar system is bound to its location where we are in the Milky Way, and we can look out into the galaxy and see where stars are bound to where their location is. Everything is related back to this invisible force called gravity. And in this case, this is an open star cluster, so they're basically bound together, but they're loosely bound. In future episodes, we're going to offer some things called globular clusters, which are huge collections of stars. Some of them are anywhere between 20,000 and up to 500,000 stars on a big ball, and they're all bound together by gravity. They're some of the older stars in the galaxy and indeed in the universe. So we're going to be looking at these clusters of stars that are bound together a lot closer than they are in this case. This is a loosely bound collection, what we call an open star cluster. So Mike is live stacking, Mike, or is this just live image, or are you stacking?
No, this is live stack. It's 255 stacks now.
255 stacks. So we can't really pick this up through binoculars. It's a difficult target through binoculars for sure, but through small scopes you can certainly pick it out. And you really want a nice wide field of view to be able to capture the whole image there anyway. So. I'm bouncing back and forth between screens here, just making sure that our connection is still solid and that kind of thing as well. So, and we're looking at what we call NGC 457, which is really the new general catalog. So we had a list of Messier objects, and then they had a list of course, a larger number of objects that followed. So it's also called the Owl Cluster, or Caldwell 13, that's another name that is given. And when we take our hand controls and bring up the object on our hand control, which a lot of the telescopes now are remotes, they have computerized controls on them. They're what we call a go-to telescope. So it comes with a hand control that you would plug in your coordinates where you are on the planet and the date and time, and then you select an item from its 30,000 object database, and it'll slew the telescope around to the object. And that's what the guys are doing here, but basically doing it through the computers. Anyway, all the objects are listed in that menu. So it can be called NGC 457. I don't know if it comes up as ET cluster, because ET is really, it's a brand, Disney brand, I guess, or whatever. But it is called Caldwell 13. That's another name given to it. So it's thought to be about 21 million years old, actually, and it's about 7,900 light years away from Earth. So we're talking almost 8,000 light years away. And it contains about 150 stars, as Mike mentioned there. It's a striking open cluster that's very easy to find and identify. NGC just kind of looks like a little stick figure with its arms spread out widely. And the shape of the little figure is very obvious. He spreads his arms out to the east and west there. When we're looking in towards Cassiopeia, so the reason why we can pick this up so clearly, and if you look at Mike's image there, there's a lot of blackness there in the background, because we're looking back into deep space, really. When we look towards Cassiopeia, we're actually looking away from the galactic center. So when you're looking at images, and I know we're running about 10 to 9 here, we might run a few minutes over if that's okay with people, but we're getting into some explanations here as Paul brings up his next image to offer here in a few minutes. So when we're looking into Cassiopeia in that area of the sky, we're really looking out into one of the spiral arms, and people say to me, you know, the sky looks so much brighter in the wintertime, or the stars look so much crisper in the wintertime than they do in the summertime, and there's a reason for that. In the summertime, we're turned around to face basically the center of the Milky Way, and Sagittarius, and that part of the arm that comes up across the top that we see the Milky Way above our heads. But in the wintertime, we kind of turn away from that area and we're looking back into deep space. So the deepness of space is really black. And then that's why the stars kind of point out at us a lot sharper, because there's a higher contrast level between the stars that we're looking at and the deep blackness of space and behind it. Also, the fact is that when we're looking at this area of the night sky, we're looking into one of the spiral arms, and the spiral arms are actually, I mean, we exist really on what we call the Orion Spur, which is a little piece off of one of the spiral arms. So as we're looking back into the spiral arm, those stars are a lot closer to us than they are the stars that are at the center of the galaxy, which are 26,000 light years away. So here we're only looking 10,000 light years away. If we turned around in the summer sky and looked towards the center of the galaxy, we're looking 26,000 light years away. So these stars are actually brighter because they're closer to us and because it's the blackness of space behind them. So that's why the image appears so nice here. Not just because the camera is capturing it, but because of the fact that there's such a high contrast between the brightness of these stars and the blackness of space in behind. In large parts of Cepheus and Perseus, our view of the outer region is kind of blocked by nearby dust clouds. So a lot of the galaxy has these huge clouds of dust and gas that strip our view from what's actually there. So these clouds can be stripped away by special telescopes, like infrared telescopes. Spitzer, for instance, can strip away those clouds, and we can see the heat signature from the stars that are in behind it. In Cassiopeia, however, the Milky Way does look much richer, and it's better visible than its surrounding constellations. So we can pick up the Milky Way quite clearly, the winter Milky Way, what we might call, that passes all the way down through Cassiopeia here and down into Perseus. And it's because in Cassiopeia there's a large gap in the dust clouds that blocks out the view of the Milky Way in Perseus and Cepheus. And this gap is known as the Cassiopeia window. The window opens up in central Cepheus, and Cepheus is, there's a little constellation that looks like a house. We could probably bring it up in Stellarium after. And it stretches right across the constellation of Cassiopeia, and it ends up at the Perseus double cluster. So that's another object that we'll be offering at a later date. When we look through Cassiopeia window, we can actually see the outward arm of our galaxy, the Perseus arm. And NGC 457 is actually in one of the clusters that is situated right in the Perseus arm. And it lies, again, anywhere between 8 and 10,000 light years out. So that's a bit about NGC 457. Let me go back to comments here. I'm not seeing any more new comments. Yes? You guys are still with me?
I'm still with you. Just,
Awful quiet there in the background. I'm not hearing anything.
the sky's starting to darken up a little bit out there, cloud over a little bit.
So we best get over to. So Mike, do you mind? Thank you, Mike, for that.
Well, no, don't do it yet, because I'm still trying to get Andromeda up and going.
Okay. Well, we'll fill the void up with. I don't know. You want to hum a few tunes, or got a couple of show tunes you can share with us, Mike, or?
Oh, I can show you. There is a band of clouds moving over top there. It's not
Look at
too
that.
awful bad in it.
Yeah.
In here in St. John.
We're expecting some rain here for the next 4 to 5 days, so it's going to be a massive cloud. We're just pretty lucky that we got the view that we did get tonight. I wasn't expecting us to be able to do this well.
And of course, I had faith.
And you had faith. Mike always says, those clouds are high, they'll go away. That's Mike's famous words. And most of the time he's right.
Okay.
Dave says never would have picked the ET.
Sorry, go ahead.
Oh, sorry. Dave McCashin says never would have picked the ET out of that if you didn't do it online. Perfect. Okay, still here. Angie says that's great. Okay, can see the double cluster with unaided eye with a diverted vision here in Little Pro. There you go. So yes, that's true. The double cluster is available through naked eye for sure. Beautiful in binoculars. And you really don't need a telescope for a number of the objects that we're going to show you here over the next number of weeks, like the Pleiades star cluster.
If you're looking at the screen right below Cassiopeia, here's Perseus here, and there's the double cluster showing up right in here.
Right in that area. There we go. So yeah,
you can see the two separate. So
that will be a target for us in future weeks here. And actually what we're probably going to do, we were talking a little bit about this, is that we're going to pick out our next number of targets for our next show. And we're not sure if our next show will be next week or actually the week after. We all work. And Mike's working on night shift, I think, Mike. Or anyway, there's some stuff coming up. So we'll be occupied for a few of these things. So we might not have the three of us on. It might be just one or two. And that's why we've got three of us here to help out. So, but in future shows, we're going to put up a little poll maybe the day after we do these live feeds, and we'll put up a selection of maybe 6 targets, and we'll get you to choose which ones you would like us to pick out. So, and whichever is the most popular, hopefully we'll be able to use that.
And while we're waiting for my target to appear, it's starting to come now. So I'll show you that in just a few seconds. But I wanted to give you the first little tidbit of the ET or the owl cluster. So here it is. So since 2019 is the year of the International Year of Indigenous Languages, it might be worth mentioning that the NGC 457 is also known as the Kachina doll cluster, and in other parts of the world is more common than ET or owl cluster. Kachina dolls are often carved from cottonwood root to instruct young girls and brides about Katsinas or Katsinism, the immortal beings that bring rain, control other aspects of the nature world, and act as messengers between humans and the spirit world. So there's another aspect of,
Wow.
of 457 that we didn't know.
Interesting.
Thanks,
Nice.
Rosanna, for that information.
Yeah, thanks, Rosanna. Always something interesting.
Absolutely. Okay, so I've got M31 up and running.
We must be getting into the observatory roof there, are we, Mike?
what's that?
Is that the observatory roof in the bottom half of your image, or is that me?
Yeah. No, it's starting to,
Yeah.
to go through the roof there.
Yeah. Oh, I think we're good there. So you're loading M31, Paul?
Oh, no, it's good. You can see it now.
Okay.
Want to share?
So
Okay, I'll share.
thanks, Mike. That was
No
excellent.
worries.
Nice view. And now we're going over to Paul. Okay, so
Okay, yep.
here's our next target.
Just a moment. It's just starting to stack there now.
Yeah. So I'll watch the comments and see if we can see anybody mentioning what we're looking at. Can anybody suggest what we're looking at?
All your sign MP. I saw ham gear.
What's your call sign, MP? I saw the ham gear.
Yeah, I don't.
There you go.
I don't have a license. I don't transmit, but I do enjoy rebuilding this old equipment and love listening.
Yeah. Mike is an incredible rebuilder of anything.
That got me
We follow.
into building the itty bitty radio astronomy dish I use to listen to solar flares and stuff like that.
Yeah, so that was pretty interesting. We're out at a star party one time, and everybody has a telescope set up, and then Mike comes out with a satellite dish. And he's listening to the sounds of Jupiter.
Yes.
It's pretty amazing. M31, Dave gets it right.
Okay.
There we are.
So we're stacking right now, and I've only got about 16 frames. So you know, in just a couple of minutes, that'll start to be more and more evident, and you'll start to see a lot more of the dust lanes. But I'll let Chris take it over about the other galaxies and all the stuff that's around M31.
Okay, thanks. So let's take a look here. Of course, I'm doing all this from memory, right? Just off the top of my head, yeah. SEA-31, better known as the Andromeda Galaxy, is of course a large spiral galaxy that's located in the constellation of Andromeda, which is what we're looking at here. So, Paul, maybe I can take share back just for a sec, and I'll bring up Stellarium and show them where we're looking. Can we do that?
Sure, absolutely.
Okay.
Set all back. I'll share here. And
I'll
give
see
me
if I
one
can
second. I have to do something here with this, and I'm not sure quite what.
I think I can just share screen from here, and I think I can grab it, and you can grab it back. Share screen.
Okay, can you?
Yeah, I think so.
Yeah.
There, so I'm starting to share, and if I go here,
There we go. I got it.
There,
Just one
okay.
sec.
Yeah.
Sure.
Okay, so I want to just point out a little bit. Can we see that? Everybody? Let me see what's going on the YouTube feed. Okay, so we're back to our, there we are. So we're back to our program Stellarium. And I want to show you where we're looking in the sky. So we're going to spin over here to our eastern sky. It's almost directly up right now. So here we are in the southern sky. So as we can see, as we move through the year here, we're only at 9:02 right now. And Pegasus, the winged horse. Let's bring in the artwork on here. Here we are. So it's an upside down winged horse. There's his head out this way. There's his legs. His wings are out this way, but we'll take that artwork back off again. And I want to show you how to find Andromeda so you can find it yourself. And when you do, you can check it out with binoculars, because it's actually not a bad view through binoculars. It's so large in the sky that it's easily visible through binoculars. So let's take a look here. So what we want to do is look in the southern horizon at 9 o'clock this time of year. There's Pisces over here. And we're going to look for this big square up here we call the Great Square of Pegasus. And that's what we call an asterism. So it's a shape in the sky. You know how you look at the sky, sometimes you see a cloud and it looks like a pig or it looks like a cow or whatever. Well, same thing here. These are asterisms. They're not really constellations, but they're things that look like other things. So we're seeing this large square. So there's a couple of ways to find it. I'm going to take that part off. And way I usually find it, and that's different with Paul, I know, and with others, is that I usually take the great square, and then I'll count out 2 stars, 1, 2, and then I'll count up 2 stars, 1, 2, and then right there, right beside that last star, you'll see this little fuzzy patch right there, and that's what we're looking at, the Andromeda Galaxy. So if I zoom back out again, another way to find it is, and I know Paul likes to use this way, is we have the W here of Cassiopeia, and that second V in the W kind of points straight down to it. So that's your arrow, that's your leading point to find Andromeda right there. Now Andromeda is the largest object, it's the farthest object, that you can see with the naked eye. Actually it was, maybe it's not any longer, and it's 2.54 million light years away. So when we see, and that's very, very visible from a dark sky location, easily with naked eye from a place like, say, Mount Carleton, which is the darkest skies in New Brunswick, or even from Fundy National Park, or any of the national parks within the country, you'd be able to pick that up naked eye easy. And if we could see the whole size of Andromeda here, if we could actually visualize the whole size of it, it's actually about 6 times larger than the full moon in the sky there. So the moon takes up about a half of a degree of sky, and this is about 3 degrees. So picture an object that's that large, 6 times larger than the full moon, but yet it's 2.5 million light years away. So that tells us how big this galaxy actually is. It contains over 1 trillion stars. So our galaxy contains between 200 and 400 billion. I don't know why they get that number, between 2 and 400. It's kind of like saying it's between $1 and 10,000. It means a lot, but the number is about 400 billion stars now in our Milky Way, and this one contains about 1 trillion stars. So as we zoom in, we can see more of it, but we're not going to reveal it that way. We're going to go back to Paul's live feed here. And
I'm just tweaking the image.
Okay, so there we are in our southern sky. Look for the great square, that big square that we see there. Count out 2 stars, count up 2 stars, and then a little fuzzy patch. Okay, I'm going to turn that back to you, Paul.
Okay, and I'm just going to try to share that again.
Okay.
And
M110 to the left, that's true, Dave, and we're going to have M32 in there as well. Okay. Thank you, Betty. We're happy to offer this. Just watching comments as they come in through on the live stream on the other computer.
okay, I'm just going to show what it is I'm trying to do, so some people can get a little bit of an idea.
Okay. You go ahead, Paul, for a second. I'm going to step away just for a second. Check with see how you go ahead for a second there.
Am I on there now?
You're not sharing yet.
No, you're not sharing.
Yeah, I am.
All I see is you. And you're pretty.
Okay. Should be there. Let me just try this. And I'm just going to try this. Hopefully I don't bugger anything up. No, it says I'm still sharing.
Yeah, you're sharing, but we're seeing the two of you on.
Sharing your Skype screen.
Yeah.
Yeah. Let's try this here. Bear with me.
Okay. Now you're sharing the YouTube screen.
Oh,
I bet we're more interesting than NGC 457, but.
yeah, I'm not real good at Skyping, so just bear with me, folks.
The Skype cluster.
Switch screen or window, there we go. So what do I want? This one, I think.
Okay, so you just had your Andromeda up there, the photo. Okay, hang on a second. It's not me. That was it. Skype. Yeah, I'm still on Skype.
Yeah, I don't know where I'm at. Chris, are you still sharing, maybe?
Let me check, Paul. I shouldn't be because I'm seeing your YouTube screen and everything. Oh, maybe I am. Just 1 second. I could be. No, I'm just asking to share now. I'll try to share here for a second. And can you see Stellarium up there now on your screen, Paul?
Yeah.
Okay, so I was sharing, so I'm going to stop sharing. Stop sharing. And now you should be able to take control.
Wow, now I see you too.
Okay.
That's why it's called YouTube.
Yeah. You did have it up before. Okay, now we're sharing. Now we're showing your desktop, Paul. And there we go. We're live. There we go. We got it.
You see Andromeda now?
Yeah, I do. Yeah.
Okay, so this is the technical stuff that we are working through. So thank you for bearing with us on this. We'll get better next time we do it.
Thanks.
That's what we keep telling ourselves anyway.
Jacob says, "Come on, boys, you can do this." Yes, we know we can. We were all born in a different time, Jacob. This isn't MS-DOS anymore, guys. Eh?
Yeah, that's right. Okay, so anyway, so what I was talking about earlier, what I was trying to show is I'm just making some adjustments on M31 just to show folks that the kind of software that we're using and the sort of things that we go through. It's really not that technically challenging. It's just a matter of knowing how to use. So I call it an equalizer of vision, which is basically this jagged line you see here. This is our dark black areas. If I push this over, you'll see that the screen will start to get darker and darker. And then if I pull it back the other way, it gets lighter. If I take this one in the middle, you can see that it'll start to darken things down or push things up. So this is just sort of a balancing act of these three controls, once we get the signal coming through. So right now I'm just trying to get it so that the dustlings are very evident. And basically what you're seeing, these areas that you see here, these dark patches, I'll blow that up so you can get a little closer. There we go, these areas here, and I can scan up and down. Chris, if you wanted to, let me see here. There we are, yeah, there's some really, really good dustling areas there. So if you look at the screen, you can see where my mouse is, if my mouse is evident. You can start to see these little dark areas, and those are dustlings. Chris, not your back. I'll just let you continue on with basically the dustlings and stuff.
Okay, great. So again, it's a distance of about 2.5 million light years away from Earth. Andromeda Galaxy is the next nearest major galaxy to our own, and it's on a collision course with our home galaxy, of course, too, the Milky Way, which will collide with us in about 4 billion years. It's actually moving towards us at about the rate of about 110 kilometers per second, but it's going to take 4 billion years to get here. The Andromeda Galaxy was named after the area of sky that it occupies, which is the constellation of Andromeda. So when we moved out from the four stars that made up part of the Great Square of Pegasus, the stars that led out to Andromeda were part of the constellation of Andromeda. And it represents the Princess Andromeda in Greek mythology. So Andromeda was chained to a rock and left to a sea monster to appease Poseidon, after her mother, Cassiopeia, had boasted that her daughter's beauty surpassed that of the sea nymphs. The princess was saved by Perseus, the Greek hero represented by the neighboring constellation. And the Andromeda Galaxy is relatively easy to find in the sky, as it is one of the brightest Messier objects. It lies in the vicinity of two prominent asterisms in the northern sky between the Great Square of Pegasus and Cassiopeia's W. The only objects listed in the Messier catalog that are brighter than M31, or Messier 31 here, are the Pleiades star cluster, which we'll offer in coming weeks, that comes up just before Orion, and the Ptolemy cluster, which is M7. And the Andromeda Galaxy is the most distant deep sky object visible to the naked eye. So when you're looking this far away, you're looking 2.5 million years back in time. So we're seeing the Andromeda Galaxy here again, as it was 2.5 million years ago. In a standard set of 10 by 50 binoculars, the galaxy appears as like an oval shape, as we see here, with a bright nucleus in the middle. And the binoculars and small telescopes, they reveal only the galaxy's bright core. But when you get to larger telescopes, they'll show its full size, which is really, it's 6 times larger than the apparent diameter of the full moon from our location, 2.5 million light years away. The Andromeda Galaxy's brightest companions, which are the dwarf galaxies shown here, Messier 32, which is the one to the right-hand side in the upper part of the screen, and then Messier 31, Messier 110, which is down to the lower left there. Those are two satellite galaxies of Andromeda, and they can also be seen in binoculars if you're holding the binoculars steady enough. And the key about binoculars, really, if you want to try to hold them steady, is to find yourself a seat. Really, first of all, take your elbows and rest them on your chest. Hold the binoculars out on the far end of the tubes, so where the largest part of the binoculars are, and then hold them up to your eyes, and that'll help to steady them quite a bit. Of course, you can also set them on a tripod. A lot of binoculars come now with a small stand that allows you to attach a 1/4x20 bolt to the bottom of it, which most tripods will accept now. So you can try them that way. And there are other means of attaching binoculars to different types of equipment as well. So Messier 31, or this Andromeda galaxy, is the largest and it's the most massive member of what we call the local group of galaxies. So there's a group of galaxies that we belong to, and it also includes the Milky Way, the Triangulum galaxy, which is our next closest, I guess, and then about 40 other smaller galaxies. So I mentioned that the Milky Way contains about 200 to 400 billion stars. We're really not sure of the number. But the Andromeda galaxy contains about 1 trillion stars, and that number was basically extrapolated. So Hubble zoomed in to a few spots on the Andromeda galaxy, and they took that number and counted the stars. And they extrapolated that number over a much larger area, and we've come up to about 1 trillion stars. Nobody actually sat there and counted them all for sure. And the two galaxies, Milky Way and Andromeda, are roughly equal in mass. But they will, Andromeda is much larger in size, and it will collide with us in about 3.75 billion years. The collision will likely result in a new giant elliptical galaxy. So there are simulations, if you go on YouTube, in different places, you can see what it would look like to be standing on the planet Earth and watching Andromeda coming towards you. And how the two of them will merge together. They'll end up in what we call an elliptical galaxy, which really doesn't have any really defined shape when it's said and done. And it's most likely that Andromeda and Milky Way have both already absorbed many other galaxies because they're so large. The Andromeda galaxy actually has a total of about 14 satellite galaxies, of which Messier 32 and 110 here are the largest and they're the easiest to observe. And M32, which is the one on the right there, actually is believed to have undergone a close encounter with Messier 31, which resulted in a smaller galaxy losing a lot of its stellar disks and undergoing a dramatic increase in star-forming activity in the central region. So if we zoomed in on that again with Hubble, and even into a lot of the spiral arms there that we're seeing with Andromeda, there's huge amounts of star formation happening within those wispy paths that we see there that are the actual disks, the arms of Andromeda. Well, I guess I shouldn't call them arms. So. And long ago, the Andromeda galaxy was actually believed to be a nebula in our own galaxy, the Milky Way. It was also known as the Great Andromeda Nebula, but as telescopes got better and people like Hubble came along, they were able to determine that that we aren't the only galaxy. And it's been this constant study with Hubble and other scopes to study more and more about Andromeda, just because it's so massive and it's easier viewed than most others. Again, it's part of our local group, and its two easily visible companions are there, pretty easy to find throughout. So that's about all I've got to say about Messier 31.
So, some tidbits of information on M31. There's a new study that was published this month in the Astrophysical Journal, and it says that Andromeda won't be the next galaxy our Milky Way slams into, although it will happen. The Large Magellanic Cloud and the Milky Way will merge about 2.5 billion years from now. And again, that's just from a recent study, and they're suggesting that. And another study says that they actually did this model now. This came from the Scientific News, and this was stuff that our fellow member from the St. John's Astronomy Club, Rosanna Armstrong, sent. And this one states that the team's models give a later than expected date for the Andromeda Milky Way smash-up, and also suggests that it will be more of a sideswipe than a head-on collision, because the distances between the stars are so great, the odds that of our own solar system will be disrupted by a merger are quite low, but the crash will definitely liven up the night sky for the creatures and that are around on the Earth 4.5 billion light years from now.
Wow.
Isn't that interesting?
Nice.
Anyway, those are tidbits of information from our
So
pal
those-
Roseanne.
Those are a couple of our satellite galaxies, the large and small Magellanic Clouds, and I guess M33. But yeah, interesting that they'll collide with us before Andromeda.
So that's starting to stack up pretty good this year. Starting to see more definition in that the Andromeda Galaxy. So it's nice to be able to see a lot more of that galaxy. And like you're right, Chris, it is so huge. The thing with this one is the telescope that I'm using is the focal length is a little bit long for this one. So that's why we're not seeing the whole thing on the screen. That's why I'm kind of moving it around so you can see bits and pieces of it. But typically, if I use the smaller telescope, you'd be able to see a lot more. You'd be able to see the whole disk of Andromeda. But the scope I have right now doesn't show that. So
you can certainly see a lot of the dust lanes there now, Paul. They're coming out much clearer. So
yeah, they're coming through very, very nicely.
looking at the color on the YouTube actually live feed, and they're not quite the same color. It's more orangey.
Oh, is it?
On the live feed? Yeah.
Okay.
But there is still a lot of structure being shown for sure. So
yeah,
I know that you captured that for a good hour. I mean, the detail there would be phenomenal.
Absolutely.
Yeah.
Absolutely. But just like I say, there's the central core, that little, the brightest star that we see.
Right.
So if you look at those dust lanes right here, and I'll just scan up just for a second, and look how far up
they stretch.
and they're still going.
Yeah.
Way beyond what my scope can show you. So
yeah, it's huge.
Pretty amazing.
It's huge to view, even through binoculars. It's amazing to. Yeah, I mean, you can get the whole thing pretty well in binoculars, but even at that, you're thinking, it's 2.5 million light years away. So the distances are just so vast in space, right?
Oh yeah. It's hard to conceive. It really is.
Oh, Peter says, "Hey, Peter, welcome aboard." Peter says, "I thought you were going to rotate the camera for a more horizontal view."
Oh, right. Yeah. I was going to do that, and I didn't. I apologize.
Oh, no worries. We'll do it again. We'll be offering this one again. We've got this one for the winters for sure now. So, Ann McAllister asked if Milky Way and Andromeda are about equal mass. Is Andromeda bigger because it's more diffuse? I would say so. There's more material, I guess, in Andromeda to form new stars, and there's more star formation happening in these wispy pieces that we see here. So that might be the reason why they say that they're of equal mass. I'm not an astrophysicist. I haven't studied it. I'm just taking data from where I was able to gather it. So from different locations today and throughout the week here as we prepared for this. But anyway, you can see how huge it is. It is massive, certainly massive. There's a better view. That's actually kind of nice there, Paul, because we've got the wide field view showing the size of it.
Yeah, and like Peter said, if I had have rotated my camera, then I would have gotten the dust lanes more up to here.
Yeah.
And this end down here a little bit more. I would have got a lot more of it. But
we'll do that for next trip around.
We'll do that the next time.
We might even offer that again, on our next live feed.
Yeah.
So getting in the next week, so we're into about 9:25 now. I guess we're almost a half hour into the show past where we were going to be, and that's kind of typical, I guess, when we get enjoying our evening and enjoying what we're offering. So if we talk about next week's show, we're going to be talking about what we're going to be able to offer. It may end up being a live feed from St. Rest Beach, if I can get a mobile phone out there, because I know that I don't think Mike or Paul will be available. We are hoping to be able to continue with a weekly format that we had suggested in the beginning. It's just that we do have other parts of our lives that we have to look after. So this is a hobby, and we'll be available as often as we possibly can. So it might be a live feed from the beach if I'm able to do it. If we have a couple of planetary targets to offer. If I'm the only one to be offering it, it may be a presentation on the night sky. I have a few presentations that I have prepared from previous dates. We could take a look around the stellarium and take a look at the list of targets that we can offer in upcoming episodes. And so we've got some ideas. It might even be simply setting up a DSLR here and showing some scopes and what you should be looking at for purchasing a new scope if it's on your Christmas list for this year, for maybe for one of your children's Christmas list for this year. So we'll come up with a format for our next episode. We know we're going to get into this issue as well when we get into cloudy skies. At the moment, they're calling for cloudy skies for the rest of the week, right until the weekend. So we're not sure exactly where we'll be, but this is what we're going to be doing. It's on the fly kind of a show. As we move ourselves along and we get our targets and we get more comfortable with that, offering it took us a long time just to get to this point, with a lot of work from these two guys here in the background, especially. I want to thank Paul and Mike both for your contributions here and for bringing this to life for all of us, for sure. So if you guys want to call it a night, we can sign off, Mike and Paul.
All right.
Anything else you'd
everybody
like to
for
say?
watching.
Yeah. Okay.
Yeah, to say the same. Thank you everybody for watching. It's been great.
We've had a great time here tonight, folks. So we'll be back to you again on next Sunday night, one way or the other. We'll be posting information on what we'll be offering in the future. Remember as well, we'll probably want to go ahead and put a list up of objects that we might want to offer in the future. So we might start a little poll and pick out some targets that we can look at in the future. So thanks, folks, for joining on. This has been a great experience for all three of us here. It's been a real pleasure to be able to bring it to you, and we hope to see you all in future weeks to come to get us all through the winter months here. So I wish you all clear skies, and we'll sign off for now. So keep commenting in the comments section if you like, and if I see comments that are popping up, I'll continue to answer the comments as we log back in later on.
Oh, and don't forget to keep clicking on those up thumbs.
And there we go. That was the other one point I wanted to make sure. Please, if you enjoyed the videos tonight and if you enjoyed the live feed, for us to continue to bring it to you, please consider clicking on the thumbs up link there. Give us a like, and also pass the word around to have others subscribe. So the more we're really here to try to reach as many bodies as we possibly can with the offerings that we're able to do. So that's our whole purpose here. And we really want to try to get into places of, we understand there's a lot of people that can't make it to the eyepiece. So it's introducing it into seniors' homes and that type of an environment as well. So if you have others that might enjoy this type of offering that we can do, please feel free to share the link out there and have others subscribe as well. Well, thanks again, folks, for tuning in, and we'll sign off for tonight, I guess. Good night, all. Thank you.